In this video, I'm going to do an optimization problem using derivatives. The given problem is that we have a rectangle that has 64 area, 64 square units, and we want to find the rectangle with the smallest perimeter but the same area, okay? So this is what it looks like. So this is my rectangle. So let's say this is length, this is height or width. So the area xy is equal to 64. So our objective here is to find a rectangle which is going to have the same area 64 but will have the smallest perimeter. All right, so let's say I call my perimeter function p of x, which is going to be 2x plus 2y. But I kind of want to express y as a function of x, but I know that xy is equal to 64. That's the area, so y must be equal to 64 over x. So that I could rewrite as 2x plus 2 times 64 over x is 128 over x. So my p of x is going to be 2x plus 128 over x. Now, since we are trying to optimize, in this particular case, minimize, what we are going to do, we are going to take the derivative of it and set it equal to 0. So f p prime of x is going to be derivative of 2x is just 2 plus derivative of 1 over x is going to be 128 times negative 1 times 1 over x square. So that's going to give me p prime of x is equal to 2 minus 128 over x square. If I were to simplify it a little bit, I'm going to get 2x square minus 128 over x square. And I'm going to set it equal to 0. And this is going to be 0 only when the numerator is 0. So that means 2x square minus 128 is equal to 0, or x square is equal to 164. X is equal to plus or minus 8. Since we are dealing with length, we are going to stick to the positive value for x, which is going to be 8. So this is my critical point, CP. Now let's go ahead and look at the function p of x is equal to 2x plus 128 over x. For this function, x cannot be 0. So x is positive, greater than 0. And we can there is no upper boundary, so it can be infinity, literally. So we are talking about the interval 0 to infinity. And the critical point, or only critical point we found here, was at x is equal to 8. So now, what is it? Is it a local max or local mean? We need to figure it out. To do that, we are going to go ahead and find the second derivative of this p of x. Okay, so second derivative, you can do a little bit of calculation. You will see that the derivative is 256 over x cubed, second derivative. You can double check it if I got it right or not. But if we evaluate this second derivative at x is equal to 8, obviously it's going to be positive, right? X is 8, going to give you 8 cubed. So it doesn't matter what it is. We really care about p double prime of x is equal to 8 is greater than 0. So that tells me, by the second derivative test, that the function has a local minimum. In this case, is going to be actually global minimum as well, because we have only one critical point and there are no boundaries. So what is it, the function value going to be now? So for x is equal to 8, okay, so p of x is going to be, p of x is equal to 8, going to be, by the way, remember, if x is 8, since the area is 64, y must also be 8, right? So I can plug this value 2 times 8 here, then 128 divided by 8. If you simplify it, you're going to get 32. So the rectangle with the smallest perimeter is going to have perimeter of 32 and is technically going to be a square because x is 8 and y is going to be 8. I hope that this discussion was helpful. Thank you very much.